Space is a theater of silence, but it is far from empty. Imagine, for a moment, a guest that doesn't knock. It doesn't announce its arrival with light or sound. It is a cosmic bullet, invisible to the naked eye, moving at the absolute speed limit of the universe, 299,792 kilometers per second. This isn't a rogue planet or a stray asteroid. This is the ultimate predator of the cosmos, a black hole. Today, we aren't just looking at these giants from a distance. We are putting Earth directly in the crosshairs of everything from a microscopic needle to a galaxy-consuming titan. What happens when gravity moves at the speed of light? We begin with the impossible, a primordial black hole. To find these, we have to look back 13.8 billion years to the chaotic seconds following the Big Bang. While most black holes are born from dying stars, these were forged in the raw, high-pressure furnace of the infant universe. Most have likely evaporated by now, but what if one survived? Imagine a black hole with the entire mass of our Earth, compressed into a sphere just 2 centimeters wide, smaller than a grape, but with the gravitational weight of 5 sextillion tons. Because it's traveling at the speed of light, it crosses the diameter of the Earth in just 0.04 seconds. You wouldn't see it coming. You'd only feel the aftermath. If this tiny visitor just swings by, the tidal forces alone would be catastrophic. Gravity isn't uniform. The site Earth closest to the black hole would be yanked with millions of times more force than the far side. The crust would groan and snap. We're talking about every volcano erupting simultaneously, tsunamis the size of skyscrapers, and the very ground beneath your feet turning into a liquid wave. But if it passes through the Earth, it becomes a needle made of infinite mass. It would pierce our planet like a bullet through an apple, leaving a wake of superheated plasma and triggering global crustal cracking. In less than a second, the Earth's orbit would be altered forever, potentially flinging us into the freezing dark of interstellar space or spiraling us into the sun. But size is a deceptive metric in space. Let's scale up to a stellar mass black hole. Meet Gaia BH1. It's the closest known black hole to us, usually sitting safely 1,560 light-years away. It has the mass of 10 suns, yet its event horizon, the point of no return, is only about 59 kilometers wide. That's a distance you could drive across in 40 minutes. If this city-sized shadow entered our solar system at light speed, the countdown to extinction would be measured in hours. From the moment it hits the Kuiper Belt, we have 5.5 hours until total planetary annihilation. As it passes Jupiter, the gas giant wouldn't have time to bleed its atmosphere into the black hole. It's moving too fast for a stable accretion disk to form. Instead, Jupiter's moons would be scattered like marbles. 30 minutes later, Mars is in the crosshairs. If the red planet isn't swallowed, it's torn apart by tidal disruption, turned into a ring of debris. On Earth, the sky begins to warp. Stars appear to swirl in a sickening dance, a phenomenon called gravitational lensing. The ground doesn't just shake, it stretches. The atmosphere begins to whistle as air is pulled toward the approaching void. When a 10-sun mass bullet hits Earth at light speed, the physics of impact change. It doesn't collide, it consumes. In 0.04 seconds, it carves a tunnel of vacuum through our core. The pressure of the mantle, suddenly missing its center, would cause the planet to collapse inward. The oceans wouldn't just rise, they would boil instantly from the friction of the shifting crust. The atmosphere would ignite. As the black hole exits the other side, it would drag a tail of Earth's molten remains with it into the dark. The black hole wouldn't even slow down. To it, we were just a momentary flicker of resistance. But there is a final boss in this cosmic horror story, Phoenix A star. This is a stupendously large black hole with a mass of 100 billion suns. Its event horizon is 590 billion kilometers wide, over 100 times the distance from the Sun to Pluto. This isn't a bullet, it's a wall. When Phoenix A star approaches at the speed of light, it doesn't hit the solar system, it swallows the neighborhood. Before it even reaches us, its gravity would overpower the Sun. Neptune and Uranus are instantly ejected into deep space. Earth's atmosphere would be stripped away in seconds, sucked into the approaching darkness like smoke into a vacuum. In the 40 milliseconds it takes for the edge of this Titan to sweep by, Earth's orbit is shattered. We would be launched like a stone from a sling, becoming a rogue planet. Without the sun's warmth, the surface would plunge to minus 270 degrees Celsius within weeks. The oceans would freeze solid. If any humans survived the initial earthquakes and the 40 milliseconds of zero-gravity chaos, they would be left in a world of eternal night, drifting toward the absolute zero of interstellar space. Black holes are the universe's way of reminding us how fragile our solid world really is. They don't just destroy matter, they rewrite the rules of time and space. Fortunately, the odds of a light-speed visitor are astronomically low, but in the vast, dark theater of the cosmos, it's always worth remembering we are moving through a gallery of giants. Sleep well.